Hello my dear children. Once again welcome back to the lecture series of Maharashtra Board Grade 12 Chemistry Halogen Derivatives. This is video number 4 where we are going to discuss the chemical properties of halogen derivatives. Before that we have a small topic to cover, that is a representation of configuration of molecules. My name is 𝐿𝐵𝗲𝗃 and you are watching 𝐿𝐵𝗃 classes. Let's get started. So here is representation of configuration of molecules. There are two ways in our syllabus. One is Fisher projection formula, the other one is wedge formula, by which we can represent an organic molecule. So what is Fisher projection formula? Here we have to first draw two cross lines. Okay, one is vertical cross line, one is vertical line and one is horizontal line crossing each other. Second point is vertical below the plane of paper. That means that this vertical line, it represents these are below the plane of the paper because it is actually a three-dimensional structure. So the vertical line represents the groups which are below the plane of the paper, and the horizontal line, these groups are above the plane of the paper. So when we write any compound, so this is your one carbon atom, okay? These two groups are below the plane and these two groups are above the plane. So here another molecule here, it is a glucose molecule basically. So you can see these are all carbon, okay? This one carbon, this is carbon, this is carbon, this is carbon. So there are 6 carbon. We know the molecular formula for glucose is C6H12 and O6. So this is the first carbon, second carbon, third carbon, fourth carbon, fifth carbon and sixth carbon. So this is C6. If you count the hydrogen, there will be 12 hydrogen, and oxygen, there will be 6 atoms of oxygen. So all this will be this is a vertical line. So all this will be below the plane and this will be above the plane. So this is how we can represent one molecule by Fisher projection formula. Another formula is wedge formula, which is a three-dimensional structure. Now there are 2 bonds which are represented by normal line, which are on the plane basically, and the remaining 2 bonds represented by one solid line, which is also called as wedge, and there will be a broken line, okay, which is also called as dashed line. So the solid line, that is a wedge, it represents the group which is above the plane, and broken line represents the group which is below the plane. Now let us see the example. See this one. Now this is a Fisher projection formula. This we are going to convert into wedge formula. So this middle carbon, first we are writing the middle carbon. This is the middle carbon. Okay. Now this is below the plane. Sorry, this the horizontal line. If you see the rule here previous, the remaining 2 bonds represent by solid line, wedge and broken line. 2 bonds are represented by normal line on the plane, solid line, wedge above the plane and broken line below the plane. Now here basically these two, the group which is above on the vertical line, they will be on the plane. Okay, these groups are on the plane. So they are just represented by normal line, COOH and CH3. These are represented by normal line. Now the group, these two are, one is above the plane, one is below the plane. Now among these two groups, the one which is of lower molecular mass, we have to consider that is below the plane. So that will be represented by a dash line or broken line. So this is your below the plane. Now the one which is above the plane, this is above the plane, this we have to drag towards this only. Okay, this is here, we have to drag this towards this and we have to show it by a wedge, a solid line, a wedge. So this is your above the plane. Okay, we'll take this example. Okay, this is carbon number 1. This is carbon number 1. So first I am putting carbon number 1 like this. Okay, now see, this will be on the plane. This is on the plane. This is lower molecular mass. This will be below the plane, and this OH will be above the plane. So first of all, on the plane will be written as a normal line. Now below the plane, this is below the plane. This hydrogen is below the plane. First, and this hydrogen is this side. So I will be drawing a broken line to represent this hydrogen. Okay. And this one is above the plane, we have to drag it towards that hydrogen. Okay, so that side. So I'll drag it towards this hydrogen and I will be showing this by a wedge because this is above the plane. This OH is above the plane. So I represented Me, I represented H, and I represented OH. Now this carbon. So this carbon is on the plane, another carbon. So I am showing it by this one. This is your first carbon. This is your second carbon. Now see this carbon. This carbon. Now this H is lower molecular mass, so this will be below the plane. The H is this side, so I will be drawing a broken line over here. This is below the plane, and this OH will be above the plane. So I will be dragging Br. The Br will be above the plane. I will be dragging Br towards H and will be showing it by a wedge. So this is your Br. Okay, and now the other carbon is carbon number 3. So that will be on the plane. I'll be showing the carbon number 3 like this. Now come to the carbon number 3. On carbon number 3, this is your lower molecular mass, this is higher molecular mass. So this is below the plane and this is above the plane. So this one, wherever it is, I will be showing it on the same side by a broken line, and chlorine I will be dragging to the same side and will be showing by a wedge like this. This is chlorine above the plane. And another one which is on the plane is your Me. So this is the representation of this molecule by wedge formula. Here already it was drawn. I showed you again. So this is how we can represent an organic molecule by Fischer projection formula or by the wedge formula. I hope you understood. I can show you one more, like suppose I'll show you one more. Suppose this is, let us draw the glucose molecule, CHO, then this is H and OH. The next carbon OH is this side, the next carbon H is here, OH is this side, next carbon H is here, OH is this side, and last one is CH2OH. So this is your glucose molecule. Let us draw this with the help of the wedge formula. So this is on the plane, first carbon, this is second carbon. So first I will draw the second carbon. This is on the plane, so that is your CHO. Now in the second carbon, this is having lower molecular mass which is below the plane, and this is this side, so I will be drawing this with a broken line, and the OH group which is above the plane will be dragging it to the same side, but will be showing it by a wedge. So this is your OH. Now the second carbon is connected to the third carbon on the plane. So this is the third carbon, okay. This is your first carbon, this is second carbon, this is the third carbon. Now come to the third carbon. On the third carbon, H will be below the plane, which is on that side. So I will be drawing H this side, and which is above the plane, I will be dragging it to the side of H, but I will be showing it with a wedge like this. So this is your OH. And another, this is connected to another carbon, this is your fourth carbon. So this is connected to the fourth carbon. This is your fourth carbon now. Now come to the fourth carbon, this is below the plane, this side it is. So I'll be showing it by below the plane by broken line. Sorry. So this is your below the plane H, and OH will be coming to the same side, will drag it to the same side, and will be showing it with a wedge here or solid line. Okay, and another carbon is carbon number 5. So carbon number 5 I will be drawing here. Now on carbon number 5, again this is below the plane, and this is this side only. So I will be drawing it like this. This is above the plane, will be showing it with a wedge above the plane, and the other one is CH2OH, that is your carbon number 6. So this is your carbon number 5 and this is your carbon number 6. So this is how any organic molecule can be shown by the wedge formula, and this is a Fischer projection formula. Okay, so I hope you understood this, the representation, how to represent the molecules. Now we'll move. So in the chemical reaction, the first reaction is the laboratory test for haloalkanes. That is when alkyl halide is reacted with aqueous solution of sodium hydroxide. So alkyl halide is reacted with aqueous solution of sodium hydroxide. It gives an alcohol and halide ion. So see the reaction, this is an alkyl halide RX. It is reacted with aqueous solution of sodium hydroxide. So basically we have taken OH minus Y because when sodium hydroxide is dissolved in water, you know that water will help sodium hydroxide to dissociate into Na plus and OH minus. So this OH minus will be reacting over here. This X, it will do what? It will, this is actually a polar bond. This is delta minus and this is delta plus. So this minus one, this is a nucleophile. This will be acting as a nucleophile here. This is nucleophile. What is nucleophile? Nucleus loving. Because it carries a negative charge. So it is a nucleus loving species which will attack this carbon atom, as this carbon atom is positively charged, and this X will be leaving, because we know that halogens are good, better leaving group. So you will be getting ROH, that is an alcohol, and halide ions are coming out from here. Okay. Now the second part of this reaction is, this is acidified with dilute HNO3 and silver nitrite. It gives a precipitate of silver halide, which confirms the presence of halogen atom in original compound. So when this halide ion, which is coming out in this reaction, it is treated with HNO3 and AgNO3. Basically, this is acidified with HNO3 in presence of AgNO3. So this mixture will give rise to Ag plus ion, and this Ag plus will react with this halide ion to give you AgX. We will get a precipitate of AgX. Now, depending on the halogen present over here, you will be getting different colored precipitate. If it is chlorine, if the halogen is chlorine, then you will be getting a white precipitate. If it is bromine, you will get a pale yellow precipitate. If it is iodine, you will be getting a yellow precipitate. So by seeing this precipitate, we understand that halogen, that halide atom, halogen atom was present in the original compound. So this is one of the laboratory tests for alkyl halide. Second chemical reaction is nucleophilic substitution reaction. Okay, so I hope everybody knows what is a nucleophile. The meaning, the literal meaning of nucleophile is, nucleo means nucleus. Nucleo word has come from nucleus. Phile means loving. Now here, what is nucleus mean? What does nucleus mean? Nucleus means, in the nucleus we know that nucleus is positively charged. So here, nucleus means the positively charged, okay, and nucleophile means it is a positively charged species. So any nucleophile means it is a positively charged loving species. Sorry, a nucleophile means it is positively charged loving species. So anything which is a positively charged loving species will be a negatively charged species either, or it will be having extra electrons, or it will be a electron rich species. Okay. So nucleophile means it is either it will carry a negative charge or it will carry extra electron, that is electron rich species. Okay. Now this is your alkyl halide RH, which is a polar bond delta plus and delta minus. Okay. And you are treating this with aqueous KOH. It is basically the previous reaction only. In presence of water, KOH will dissociate as K plus and OH minus, and this OH minus, this will be acting as a good nucleophile. It will be attacking the carbon here, and X will be coming out from here. So you'll be getting ROH. There will be a bond between carbon and OH, and this KX will be, X minus is coming out, which is reacting with K plus to give you KX. Okay. So let us take for particular example, ethyl bromide, or you can call it as bromoethane plus KOH aqueous. This KBr will be coming out from here, and you'll be getting CH3 CH2OH, which is your ethyl alcohol, and the byproduct is KBr. Second reaction, under the nucleophilic substitution reaction only, this was the first one. Now the second one is action of sodium alkoxide. What is an alkoxide? Alkoxide is OR minus. This is an alkoxide. Now when you say sodium alkoxide, just add sodium to it. So this is sodium alkoxide. Now if your R group is CH3, then it is methyl sodium methoxide. If your R group is C2H5, then it is sodium ethoxide, and so on. Okay. So now this is your alkyl halide, and you are treating this with sodium alkoxide. We have taken a different R group here, which is different to this R group. What happens is this NaX will be coming out, okay, because sodium, potassium, these are having a lot of attraction towards the halogen. So NaX is coming out and ROR dash is forming. What is this? This is an ether. So ether is formed over here. Okay, so let us see. Okay, we'll do this later on. Okay, the next one is, so we are seeing the example here, CH3Br, that is methyl bromide, is reacted with sodium methoxide. See, this is your methoxide. R group is methyl group, so sodium methoxide. So what happens is NaBr comes out from here and you get CH3OCH3, which is your dimethyl ether. Okay. Another example, C2H5Br, which is ethyl bromide, NaOCH3, again sodium methoxide. NaBr will be coming out from here and we'll be getting C2H5OCH3. This is now according to the alphabetical order, it is ethyl methyl ether. Okay, and the byproduct is NaBr. Next example, C2H5Br plus NaOC2H5. C2H5Br is called as ethyl bromide and this is sodium ethoxide. Okay, again NaBr is coming out from here. You are getting C2H5O C2H5. What is the name? Diethyl ether plus NaBr. Okay? Now the next nucleophilic substitution reaction is with action of alcoholic ammonia, where we get primary amine as the product. So now here Rx is again alkyl halide and we are reacting with ammonia. See, what is your ammonia? Ammonia is N, H, H and H with one lone pair of electron. This is your ammonia. So I can write it as H and NH2. I wrote it as H and NH2 together. Okay. So see here, H and NH2. This is having a lone pair of electron. So what happens is HX comes out from here. HX comes out and you get our NH2. NH2 group is what? Primary amine. So you get a primary amine. Okay. Let us see the next reaction. The example from here. CH3CH2Br, that is your ethyl bromide plus alcoholic ammonia. HBr will be coming out and we'll be getting CH3CH2NH2, CH3CH2NH2, which is your ethyl amine. So HBr is a byproduct. This one is CH3CH3CH2Br. This is N-propyl bromide. Once we get more than 3 carbon atom, we have to write it. If it is a straight chain, we have to write it as N-propyl, because now you know that iso also can be possible. So we will write N-propyl bromide, and from here HBr will be coming out. So you get CH3CH2CH2NH2, that is propyl amine plus HBr. Okay. Come to the next nucleophilic substitution. It is action of silver carboxylate and formation of ester. Now what is silver carboxylate? See, this is your carboxylic acid, CH3, C double bond O, OH. This is your carboxylic acid. Now from here, if I remove the hydrogen, we get CH3, C double bond O minus, which is called as carboxylate ion. Okay. Now if I add sodium to it, then it will be sodium carboxylate. If I add silver to it, it will be silver carboxylate. So if I add OAG here, then it will be silver carboxylate. So this is what I have taken here, RCOOAG. Here instead of CH3, I can take a R group. So according to the R group, the name of the carboxylate will be. Okay. So RCOOAG plus R dash X, that is your alkyl halide. So what happens is AgX comes out and you get RCOOR dash, RCOOR dash, which is your ester, plus AgX is the byproduct. So let us take example, CH3COOAG. Now what is the name of this? Silver acetate, because with 2 carbon atom, the carboxylate ion is called as acetate ion commonly. And if you want to write down the IUPAC name, then it will be silver ethanoate. Okay. And methyl bromide. So AgBr, you remove AgBr from here, we get CH3COOCH3. CH3COOCH3. Now how this ester will be named? This part we take as alkyl and this part we take as alkanoate. In IUPAC I am talking about. So it will be methyl ethanoate. That is the IUPAC name. Methyl ethanoate. N-O-8. This is IUPAC name. If you write down the common name, then it is methyl acetate plus AgBr is the byproduct. Another example, CH3COOAg, again silver acetate plus C2H5Br, that is ethyl bromide. AgBr will be coming out from here. So CH3COOC2H5. Now the name is ethyl acetate. Okay. This is CH3CH2COOAg. There are 3 carbon atoms. So it is called as silver propionate. Propionate is the common name. If you write down the IUPAC, then it will be propanoate. Propanoate. Okay. So silver propionate plus methyl bromide. AgBr you just remove and join the rest of the things. So CH3CH2COOCH3, that is your methyl propionate. Okay. So this is your the reaction with silver carboxylate. Okay. So the next substitution, nucleophilic substitution reaction is with alcoholic potassium cyanide. Alcoholic potassium cyanide, and the formation of alkyl cyanide will take place. So this is your alkyl halide and this is alcoholic potassium cyanide. Now KCN is potassium cyanide, which is an ionic bond. So when you dissolve this into alcohol, it will give you K plus and Cn minus. So Cn minus is a nucleophile over here. The Cn minus will attack this R and X will be liberated as X minus, which will further react with K plus to give you Kx. So basically what is happening? This Kx is removed from here and you are getting RCN. This is called as alkyl cyanide, or it is a nitrile. Cyanide group is also called as nitrile, and the byproduct is Kx. So we are taking an example, CH3Br, that is methyl bromide plus KCN. So this KBr you just remove from here and you get CH3CN. Now CH3CN has got 3 names. Okay. The first one you can call it as methyl cyanide. Okay. The common name of that is acetonitrile. Acid for 2 carbon atoms. So acetonitrile, and the IUPAC name will be ethane nitrile. There are 2 carbon atoms, so ethane, and N for we write nitrile. So ethane nitrile plus KBr. Okay. So this is 1 and this is 2. So that is why it is aceto or it is ethane. Okay. Let us go to the next example. C2H5Br, that is ethyl bromide plus KCN. So KBr will be coming out from here and you get C2H5CN. What is the name? Propane nitrile. There are 3 carbon atoms. So propane nitrile, or you can call it as ethyl cyanide. When you say cyanide, you are already counting this carbon. So then you have to just see these 2 carbon, whatever number of carbon is there in the R part. So cyanide, when you say cyanide, you have already counted this carbon. So then just understood, just see the carbon in the R part. So that is ethyl cyanide. But when you say nitrile, then it is propane nitrile. Nitrile, we call it only for N. It is nitrile. Okay. So the next nucleophilic substitution reaction is with silver cyanide. Now silver cyanide is AgCN. Okay. AgCN is a covalent compound. It is a covalent compound. So here the attack will be with the lone pair of nitrogen. In KCN, the attack was with carbon, the minus sign on the carbon, because in the KCN, if you remember, it is dissociating as K plus and Cn minus. The minus sign on the carbon is attacking the R group here. But here, the lone pair of nitrogen will be attacking the R group. So if nitrogen attacks the R group, so the attack will be like this, and this is coming out. So finally AgX will be coming out from here, and the bond will be between carbon and nitrogen. So we get RNC. This is the isocyanide. This is the difference. Okay, with KCN we get cyanide, and with AgCN we get isocyanide. I told you the reason. KCN is a ionic compound. It dissociates as K plus and Cn minus. So Cn, the negative charge on carbon attacks the carbon atom over here, but in AgCN it is a covalent molecule, so the lone pair of nitrogen attacks the carbon over here. So accordingly we get isocyanide and cyanide. In the previous case we get cyanide, and here with AgCN we get isocyanide. Okay, so this is the example, CH3Cl plus AgCN. Just remove AgCl from here, you get CH3NC, that is methyl isocyanide. Another example is CH3CH2Br, ethyl bromide plus AgCN. Just remove AgBr, you get CH3CH2NC, that is ethyl isocyanide. This is propyl chloride. Remove AgCN, you get CH3CH2CH2NC, that is propyl isocyanide. Okay, so this is your nucleophilic substitution reaction number F. Now the next reaction is with potassium nitrite. Potassium nitrite is basically KNO2, but if you see the structure of it, it is KON double bond O. This is the structure of potassium nitrite. Okay. So when alkyl halide is treated with this, KX comes out from here and you get RONO. This is basically alkyl nitrite. You get alkyl nitrite. So take an example, methyl bromide this is plus KONO. So KBr comes out from here, you get CH3ONO, that is methyl nitrite. The name of this compound is methyl nitrite. Okay. Next one is CH3CH2Br plus KONO. KBr comes out and you get ethyl nitrite. Always remember, don't write it as CH3CH2NO2. Don't write it this way. This is nitroethane. Okay, where the nitrogen is attached to the carbon. But here we are getting CH3CH2ON double bond O. Here oxygen is attached to the carbon. So in nitrite, oxygen gets attached to the carbon. Always remember. Okay, action of silver nitrite. Now here you get the nitro compound, because again the same reason, this was a ionic compound, so this dissociates as K plus and ONO minus this way. So O minus attacks this carbon. Okay, but here this is a covalent compound, so the lone pair of nitrogen attacks this carbon. So here the bond forms between carbon and nitrogen. So we get a nitroalkane over here. Okay, AgX comes out and we get nitroalkane plus this. So take example, CH3Br methyl bromide plus AgONO. AgBr comes out and you get CH3NO2. Now here you will get NO2, I told you, because this lone pair will be attacking this carbon over here and this will be coming out. So we get nitromethane, sorry, one carbon atom, so nitromethane. This is CH3CH2Br ethyl bromide plus AgONO. So AgBr comes out and you get CH3CH2NO2, that is nitroethane. Okay. Oh, so here we completed with the nucleophilic substitution reaction of alkyl halides. Now in the next video, I am going to come with another chemical properties of alkyl halide. Thank you so much. If you feel these videos are beneficial to you, please subscribe the channel and press the like button. Thank you. Stay tuned.